In this video, we are going to understand that how to draw a tangent from the circle if the point is given outside the circle. Hello my awesome students, welcome back to my channel Akshar. I am Nana and I usually make videos related to NCERT solutions for classes 9 to 12. So let's have an introduction that what you are going to understand in this video. So we are going to solve some examples of exercise 11.1 and how to draw a tangent from the point outside the circle, and we will also solve the first question of exercise 11.1, and link for the remaining questions is given in the description box for the chapter construction, chapter number 11 of class 10. So let's start our today's topic. Examples of exercise 11.2 of class 10th, which is construction. Okay, so till now we have learned that how to do construction of triangles in exercise 11.1. so now in this exercise we are going to learn that how to draw tangents to a circle. In the previous chapter of circles, I have told you in my previous videos that how to draw a tangent and what is a tangent. Tangent is what? If you have not seen my that video, please see my those videos first. Okay, so let me give you a brief recap of the thing that what is actually a tangent. So tangent is what? Tangent is any line which is touching the circle at a single point. This is called as a tangent. If it is touching the circle at a single point, then this will be called as a tangent, right? So the main concept is that this point should lie on the circle. Only then it will be called as a tangent, right? If the point is lying inside the circle, then any line passing through the circle will not be called as a tangent. Why? Because it is now touching the circle at 2 points. So the condition for being a tangent is that it should touch the circle at a single point, right? So either the point can be inside the circle. If the point is inside the circle, then there can be no tangent passing through this point. Okay, so in the first point in your NCERT book, it is given that if the point lies inside the circle, this point, then no tangent can be there on this point, right? Second, if the point lies on the circle, then there is a tangent, then there is a tangent. This is a tangent. Okay, and we have learned in a theorem that if there is a tangent passing through the circle, then at the point of contact, radius is perpendicular to the tangent. Okay, so if any circle is given to you and you have to draw a tangent and the point lies on the circle and you have to draw tangent on this point, then how you will proceed? You know this property that radius is perpendicular to the tangent at the point of contact. Okay, so suppose this is the center O. So if you have to draw a tangent at this point, then what you will do? You will join the radius. You will draw a radius from this point and draw an angle of 90 degree. So this straight line will be called as the tangent of the circle. Okay, if the point lies outside the circle, so outside the circle, we have learned in the theorem 10.2 that if the point is lying outside the circle, then two tangents can be drawn from this point and both the tangents are equal in length. Okay, so if this point is lying outside the circle, then there will be how many tangents? Then there will be two tangents to the circle from this point. So we are going to learn in this exercise that how to draw these two tangents if the point is lying outside the circle. Because if the point is inside the circle, then no tangent is possible. If the point is on the circle, then it is very simple that draw the radius and draw perpendicular. But if the point is outside the circle, then how to draw these two tangents? Okay, so let us start solving the very first question, which is example number 3, construction number 11.3, which says that to construct the tangents to a circle from a point outside it. To construct the tangents to a circle from a point outside it, that means, which I have told you right now, that we have to understand that we are going to construct two tangents to a circle from a point which is outside the circle. Okay, right? For that, what is given to you? Suppose any circle is given to you with the center O and a point P outside the circle. We have to construct two tangents. These two tangents we have to construct. Suppose the name is Q and the name of this point is R. Construct two tangents from point P to the circle. Okay, so let's start solving it. So for that, what we are going to do, we are going to draw any circle of any radius, right? Because radius is not given to us, so this time we are going to draw an circle with the center O. Okay, suppose this is my circle, this is my center O, right? Now this point is given to me, which is suppose point P. I can put point at any place because this is just an example to tell you how to solve the remaining questions. So length is not given to us, so we can draw this point at any point, at any distance. Okay, so now what I have to do, I have to draw a perpendicular bisector on this line, right? So how I will draw perpendicular bisector? I will measure this. This is my 5.6, right? So this is my 5.6 approx. So half of 5.6 is what? Because I have to draw bisector. So 5.6 divided by 2 will give me what? It will give me 2.8. So I will open my compass equal to 2.8, this much, and draw an arc upper and draw an arc at the lower position from the same point P. Okay, and from the point O also I am going to draw an arc here and an arc here. If the arcs are not intersecting with each other, then what you have to do, you have to extend your arc so that it is going to intersect at a point, right? So increase your arcs till it is going to intersect with each other, because the points at which it is going to intersect will be your perpendicular bisector. So now join these points. So this is going to be your perpendicular bisector. Suppose this is your M midpoint, right? So now draw, take OM as a center, as a radius, take OM as a radius and M as the center. Draw another circle which is going to intersect our given circle at the 2 points. Name these 2 points. Suppose give the name to these points as R and this is my point Q. So if I am going to join these 2 points PQ and PR, so these will be my required tangents which I have to draw. Okay, so let's write down the steps which we have done. We have done in our construction. What we have done, we have draw a circle with the center O. So you can add on the dimensions given to you in the actual questions in these steps, right? Then step number 2, take any point P outside the circle, right? Next, what we have done, after taking this point P, we have drawn this bisector on the line OP. Step 3 will be what? Draw a bisector on the line PO. Okay, so step number 4 is what? We have drawn this bisector. Step number 4 will be what? Join. Step number 4 was what? Take OM as radius and M as center of the circle and M as center. Draw a new circle. Okay. Next, step number 5 was what? Step number 5 was that let it intersect our given circle. Let it intersect our given circle at point Q and R. At point Q and R. Okay. So the last step, step number 6 was what? Step number 6 was that join PQ and PR, which are our required tangents. Okay, so you have to write down the same steps in each and every question, but the difference will be what? The difference will be that you have to add on your given dimensions in the question. Okay, so let us start now exercise 11.2. Right, exercise 11.2 says what? That draw a circle of radius 6 centimeter. So this time, see, this time dimensions are given to you that the given circle is of radius 6 centimeter. Earlier what we were doing, we were drawing any random circle, but this time it is given to us that this radius is equal to 6 centimeter, and from a point 10 centimeter away from the center. So this is also 6 and 10 centimeter away from the center. So 6 is this and 4 centimeter will be this. So suppose this is my point P. Construct the pair of tangents to the circle and measure their length. From this point P, you have to draw two tangents and measure their length. So it is the similar question, right? So let us start solving it. So for drawing this circle 6 centimeter, open your arc equal to 6 centimeter. So you can see very clearly I am opening my arc equal to 6 centimeter, and I will draw a circle of 6 centimeter. Okay, so this is my center and I am giving it name as O. Okay, so this is my 6 centimeter, right? So this is my 6 centimeter, and from the center 10 at the 10 centimeter and another point is there, which is the point outside the circle, and I am going to give it name as suppose P. So my next step is what? My next step is that I have to draw perpendicular bisector at this line. So that means what I will do, I will open my compass randomly, which is half more than the given line, right? Randomly you have to open your compass of any length which is half more than the given line, and draw two arcs, one above the circle, one above the line and one below the line from both the points, point P and point O. Okay, now join these two points. When you will join these 2 points, then this point will be your midpoint of this line. So this is your 10 centimeter. So midpoint will be what? Midpoint will be 5. So you can see very clearly that the midpoint is, this point is my 5 centimeter. Okay. So moving to the next step. Next step is what? Now take this PM as the PM or MO as the, because this is the midpoint, so it doesn't matter that you are taking PM as the center or you are taking MO as the center. Draw another circle which is going to intersect our given circle at 2 points, which we will name them as point Q and point R. So now join these 2 points, point PQ and point PR. These will be going to be your 2 required tangents. Okay, so these are the 2 tangents which we have to draw on this given circle, right? So measure this length. In the question it is given to you that you have to measure the length also. So you can measure the length from the simply by using the scale. Okay, so these two will be equal in length. So both of these are coming approximately equal to 8.2 centimeter. Why both of these will be equal? Because according to theorem number 10.2, it is said that if any two tangents are drawn to a circle from an exterior point, then they are equal in length. If you find this video useful, then please do like, share and subscribe my channel so that you can get new updates of my videos. So let's meet in the next video in which we are going to solve the remaining questions of exercise 11.2. Till then, take care and bye bye.